Good afternoon, everyone. Welcome to today's Tech Tuesday. My name is Vanessa, and today we're going to be talking about 3D graphics with Rob Dietz, who manages our instructional technologies team in ITS. So, Rob's going to kind of explain to us how he creates 3D graphics, some of the work that he's done, and then the tools that you'll need to create your own 3D graphics if you'd like to go that route. Before we begin, I just wanted to let everyone know we are expecting quite a few people to log in, so everyone's mic is on mute. However, if you have any questions at any point during the session, please feel free to pop them in the chat or raise your hand if you'd like to come off the mic, and we can do that for you. We'll be stopping every so often to take your questions. I'm also recording today's session, so later today, you'll get a follow-up email with a link to the recording. Feel free to look at it whenever you'd like to go over any of the material again, or even share it with some of your colleagues who were unable to attend today. So without further ado, I am going to hand it off to Rob. Thanks for being here today.
Hi everyone, thanks for joining. Thank you, Vanessa. I've had a chance over the last couple years to work mostly with our anatomy department on some 3D graphics techniques for really just capturing some of the anatomy specimens they have in their lab and turning those into 3D models that then can be used in instructional materials. So some of the things I do are going to be a little bit beyond what we can just, do on the fly in the session, but other things you can kind of follow along at home and download some models and insert them in a slideshow and things like that. So let's get started. Um, so for here's what we're going to cover today. I'm also going to go beyond just 3D models and introduce 360-degree photos too. So you can think of we're going to work with models, which are going to be, objects. We're going to work with environments or scenes, which are kind of like wraparound photographs. Um, so let's start first with the models. I'd like to invite everyone, and I'm going to put this link in the chat here. Um, let me just grab that real quick. Wait, I guess I got to get out of make it out of my mode here, but I just want to give everyone a chance to actually get a model on your computer that you can mess around with as we start here. So this is a website called fab.com, and with this one, it used to be Sketchfab plus a few other 3D modeling apps had a marketplace for sharing 3D models, and now it's kind of been combined into this bigger company called Fab, and they have a lot of models that we can check out there. So let me show you what you'll see if you go there. So if you go to uh, and just so I'm clear, is everyone seeing my browser screen now?
Yes, we can see all the pumpkins.
Okay, great. So I went to fab.com, I searched for Halloween pumpkin, and I filtered it by free models. And so from there, I just grabbed this one called Halloween Pumpkin Low Poly. Once you get that one, you've got a few download formats that it shows you can use here, and you can just download one of those. I'd say if you want to look at things on a Mac, go for the USDZ format. If you want to look at things more like on the web or on a PC, then go with the GLB, GLTF formats. And I'll talk a little bit about those as we go. Once you get that, once you've got that model, then you can depending on your platform, you can either use a Mac preview to look at your model. Let me pull up. Oh, here's preview. So if you're on a Mac, you can just pull it up in preview. You get a nice little model here that you can manipulate. On a PC, on Windows, it'll probably be like Paint or Paint 3D, which is included in Windows. And you can at least just, view your model here. Um, a little bit on what you're looking at. So a 3D model is basically a mesh, which are points in space connected by lines and curves, with either a material or both a material and a texture around it. So I've got this sort of you know, similar thing in real life. We've got a bunny, a chocolate bunny, and it's got a wrapper around it. So you can think of the chocolate as the mesh. So that's the actual 3D model. And then it's got the texture and the material, which is the foil. So you can see on this foil here, you've got mostly shiny golden material. So that's very emissive. It emits light, it reflects light. Maybe the darker eyes and ears and nose, those are going to be, less shiny and give it a different kind of characteristic when you put light on the 3D model. But this is basically how these models work. The pumpkin has a shape, but then it also has, the orange material, it has the green stem material, it has light coming from inside, it has a lot of different things going on, and that's what a 3D model is. If depending on which format you downloaded, you'll probably get a package of files. So when you download the model, you've got kind of a collection here. So I'm showing you the GLTF version, and you see it's got a scene and a zip file. So this is basically the scene is basically a it's kind of like a JavaScript file that just uh, tells the computer what to bring in and where to put it. And then it's got a bunch of textures. So you've got a base color, an emissive layer, a metallic roughness layer, and a normal layer. And these things kind of define how the model looks in a virtual camera and with virtual lighting in a scene. A little close up on those different texture layers there. So base color looks like a pretty realistic pumpkin color that you see there. The emissive, that's showing you, where the light is coming out of it. Metallic roughness, that's kind of like shininess. It's showing, some of the elements are shiny, others are more matte or dull. And then the normal map also gives it a little bit of its 3D character. USDZ format is a little different. This is Apple collaborated with Pixar, who make 3D animation films, and they've introduced this other open format that Apple has adopted and put into um, all their devices, and it has a lot of special uses in augmented reality and virtual reality. And with this format, we can actually create our own models using Apple photogrammetry. So uh, the image here is not that high res, but basically you start with some real photographs of a pizza. You go through the Apple photogrammetry system and you end up with a 3D model of your pizza. And a little bit of background on this methodology. Um, Apple's iPhones and iPads over the last several years have included a LiDAR scanner. So if you look at the image, basically this big thing, there's two lenses and then there's a LiDAR scanner here. And this is um, what helps you detect distance and depth. So using that plus the lenses of the camera can give you a really good way to turn a 3D object in real space into a 3D object in virtual space. This is a little bit of a artist rendering of what this LiDAR scanner kind of looks like to the iPhone. And so Apple has a app for iOS called Reality Composer, and within that you can create 3D models. You can import 3D models from Apple's library or elsewhere, but I think the coolest feature of it is you can create your own models from things in your real world. So this is an example. There's a wooden castle, and using an iPad or iPhone, you can scan it. So you're basically taking hundreds of photographs all around it. And once you get all those photographs, it generates this kind of uh, virtual model of the real world object. So this kind of just describes a little bit of that process. Usually you do three passes. You kind of go in the middle, up above, down below, and go all the way around the object. Sometimes, depending on the type of object, you're asked to turn it on the side or turn it upside down, so you get all sides of the object. Something that I've done with this, along with the anatomy department, is taking some of their anatomy specimens. In this case, we've got a couple of brain specimens here, and turning those into 3D objects. So when you do a dissection lab, you kind of have a really good experience in the moment, and you learn a lot. But then once you've cut up the specimens, they're kind of done, and you have some photographs left over, but you don't have the specimens. So we're trying to take that a step further and actually you have reusable 3D models of some of these specimens for learning. A little bit of a close up there. So this is me with an iPhone inside of a light box that I can get, good even lighting as I walk around the model and capture the images. What else here? Okay, just a little bit about what you can do once you get the models. You can, if you're on Apple and you have the USDZ format, you can view them in preview, as I showed earlier. You could also just pop it into a Pages document or a Keynote presentation. And then if you're using some of the other formats, you can do the same in Microsoft's Word or PowerPoint. So actually, before we go to questions, let me actually show you how you can share some of these models. So if you have your jack-o'-lantern, I'm going to come out of my presentation. I'll just make a new PowerPoint, and let's just put a model in here. This actually, I'm using the desktop version. So if you're on a Mac or a Windows, the 3D model feature currently only works on the actual desktop app, not in O365 in a browser yet. So I've got a presentation. I can uh, insert my model that I've already downloaded. So if I go up to Insert and then 3D Models, and then I can pick this device, and now I will put in my pumpkin. So I've got for PowerPoint, you're going to want to use either the GLB or GLTF. That's the format that's ready to go um, for this one. You can always convert between formats, but for now, so now I've got just like putting an image in, you can resize it, you can move it around, but the coolest thing is you can actually, rotate it. So now if you go in the center area, I can find, what is the kind of angle or view that I want to put here. And you can even go further and animate it if you want. So I'll show you a few examples later in the presentation where you see, a 3D animation of a 3D object. And so with that, let's see if there's any questions at this point on 3D models and objects.
Not a question yet. I do have somebody that mentioned they were getting an error message about FBX security vulnerability. I've asked that user to just reach out to us after the session. I'm not sure if that has to do
Mhm.
with the device or the OS, but Louise, please, if you have a chance after the session, I'm going to send a follow-up email. You can just reply back, and then we can figure out what the issue might be.
Okay. Yeah. Um, all right. So here's another 3D object. So this is a picture of one of those brains that was scanned in the anatomy lab. And if I press the next button on my slideshow, you can see it's just got a rotation animation applied to it. So this is a new thing that you could, only do with a 3D object.
Rob, we do have one question that came up from Ashwin. Do you know of a way to export 3D files from a radiology data set, like a knee fracture, for example?
Um, I'd love to look at that with you. I've seen some examples around Weill Cornell of, I guess, people using DICOM viewers for viewing, radiology imaging. So, if you have something like that, I'd love to, work with you and see what you could do with that, based on some of the technologies that we have around the college.
We also have a question that just came in from Kenneth. What SAS or R packages write out 3D plots that we could export to these formats? Are you familiar with any, Rob?
Um, I'm mostly coming at it from a 3D designer point of view. So I use Blender, which is a free open source 3D modeling app. And one thing you can do with it, even if you're not a 3D designer, is you can just import a model of a certain format and export a model of another format. So Kenneth, if you can just, tell me like what files you're working with, I can tell you at least yes or no, could we use this free application to export in another format that then you can, share in some of these ways. Um, okay, so next topic, 360-degree photos. So think about instead of looking at something, walking around it, capturing it, holding it, you're just you are the one in the middle and you're looking around and what you see is a wraparound 3D photograph. Um, there are some ways to capture these just using an iPhone. Newer, really new iPhones, I think an iPhone 15 or 16 can do some of this without a third-party app, but the third-party apps work for all the Apple devices, and it just gives you a way kind of do the same thing we were doing with the photogrammetry. Instead of walking around the object, taking lots of photos and turning it into a model, you're standing in one, you're standing in still in the middle and you're looking around at your environment at different angles and it's taking lots of photographs and then stitching those together for you. Um, you can also use a special purpose 360-degree camera. So this is a great way to instead of taking hundreds of photos and stitching them together, you're just taking two photos, and the device, the camera itself, stitches them together for you and gives you a spherical image. So this is an example. This is a Ryko camera similar to one that we use in our office. There's a few other models. Insta360 is another company that makes some of these. And these are, really easy because you just push the shutter button and you get your two fisheye lens photos that are then stitched together, and it returns you a full 360-degree image. A little bit of background on kind of how this works, something you might be more familiar with. If you imagine a globe of the world flattened onto, into a rectangle, that's basically what these images are. So let me, one thing about these images though is you can't, you can't necessarily do anything with it until you have a dedicated application. Because if you're just looking at the Mercator projection rectangular image of your spherical photo, not very immersive, not looks distorted. But once you put it into uh, an actual dedicated app, then you can explore it in 3 dimensions. So let me jump out of here and go into my browser and show you just what one of these can look like. So, this is a photograph taken at Rockefeller University, one of the tri-institutional MD PhD program spaces. And I'm I took a spherical photo there, and now I'm showing you how it looks in this dedicated viewer. This one's on the web using H5P, which is exists as a free open source interactive web platform. And I've placed this in here, one photograph in here in one scene, and I put a one text label here. So just to define, like, here's an interactive feature. You can see the text label moves with the photograph. If I select it, I can get more information on that. And I'll actually just show you how I built this, and then we can discuss it a little bit. So if I go, I'm just going to create a new piece of content. And you can see there's lots of options with H5P, different kinds of interactive elements. I'm going to pick the virtual tour, and it is asking me, to create the first scene. I'll just give the tour a title. And we will create a new scene here. And I will add a background image. And let's see, I think I've got some 360 photos here. Just put a slightly different one than you saw before. So, this is what the image looks like not put into a dedicated viewer, just kind of a distorted uh, image. And the edges here on the sides and top bottom represent where it's been stitched. So where the two lenses created images that had a little bit of overlap, enough overlap that it could uh, merge them together to form the full spherical image. Okay, so I've got one background image in this scene. I can just say done there. And now you'll see what that image looks like in the viewer. So I've got, looks like it's me standing about where one of these meeting tables is in the same building. Once you can stitch multiple scenes together, and I'll show you that next to create an entire virtual tour. You can't, walk seamlessly from one space to another like you might do in a VR situation. It is just kind of like one photograph taken at one point in space, and then you teleport to another point in space if you have a virtual tour set up using just photographs. But within this virtual tour H5P system, I can add elements. So, I could have another scene that has a little icon to get to it. I could put in a text label. We'll see. And then I get to, put this element somewhere. So I can put this label wherever I want. And then once I save it, I've got a interactive elements in my virtual tour. And you can put lots of things here, videos, web links, um, links to other scenes, etc. Another thing you can do is decide what do you want your starting position to be. So this isn't that great. It just sort of puts your face right by the glass. Maybe the best starting position for this one would be, something like this. I can frame that the way I want, and then I can set my starting position, and it'll remember that for the scene. I could go ahead and make additional scenes if I wanted to. I'll show you. So here's an example of one that I've already made. This is a virtual tour of the library at 1300 York. And this one has multiple scenes that you can navigate through. So starting here, I'm in the main entrance to the library. I can see, there's a smart desk here. There could be, links to actually do something. Um, Here's some information about the fancy TV they have there. And if I move forward now, I'm going to actually teleport to another place where a photograph was taken, and I can continue the tour. Can go down the steps. I can go into the computer classroom. There's me where I didn't get out of the way when I took the photo. Um, and you can see how, just with a few photographs, you could make a virtual tour that just gives someone a clear idea of how to navigate in a space. Question coming in, which cameras do I recommend? Um, we have the Ryko Z1. It's actually I think it's the best one that's around $1,000 or less that for still photographs. A lot of these cameras are built more for videos. I think that's the most popular use of this technology is to make 360 videos and share them on Facebook or wherever else you might do that. So we specifically were looking for the best specs for still photography rather than video, and the Ryko Z1 has a really nice big sensor that takes great photos. Any other questions?
Not yet, Rob.
Okay. Okay, so another thing I wanted to share, making, some of these interactive, making them do things. Let's play this video. This is an app we built for it's kind of like a model selector. So I'll just play the video. Um, you can see um, there's one, we have one model that we captured in the anatomy lab. You can zoom, pan, rotate it. This would work, on an iPad. This would work on a Mac or a PC. It could also work within VR. And the idea is, we're just putting different specimens that we scanned into this one app and giving an option to select what you want to look for here. This is built with Unity. Um, and one of the advantages of that is it can be ported out to really any platform. Here's another one, slightly different. This one takes, a single model of a brain and then gives some interactive layers to it so that eventually we can map out a lot of the features of the brain that would be useful for students to understand.
Hey Rob, we got a question about whether it's possible to get a link or a way to access these models for clinical use to teach residents in radiology.
Um, yes, contact me and I'll get in touch with the anatomy department and we'll see what the best way is to share that. Right now the anatomy department has sort of run with this process and they've scanned, dozens, maybe even more specimens throughout the year. So they're getting a really good library of specimens that we can definitely share around and also work with other departments to see what are the best formats for sharing them. And yeah, I'd love to work with other types of 3D imagery. I know there's a lot of histology as well as radiology imaging that exists, and we already have libraries of that. So finding ways to share that and reuse that would be interesting too. Um, any other questions about anything in the presentation?
Rob, do you have any recommendations? Those photos that you showed of you taking pictures of the brain with your iPhone or iPad and the light box,
Yeah.
any recommendations on the setup of what's the best way to kind of lay an object out to get the best quality image? Because I noticed that you're in a lab and you've got a light box.
Mhm.
Do you have recommendations if you don't necessarily have all of those tools of how to get the best image you can?
Yeah, I mean, a lot of it is trial and error. So this is actually, if you look at the image in the lower right, we're doing something funky there where we actually have this plexiglass uh, sort of rectangle there that the brain is kind of sitting on. And we noticed as we cut different slices of the brain, it's not, it's not a piece of marble. It's kind of a squishy, fleshy structure. So as we cut pieces off, it doesn't necessarily hold its shape as well as it did when we had the complete brain. So this is one of the ways that we were able to view the slice. So we wanted to actually see the cut and get, a little bit of an inside view of that. And we found that, this method worked well. And once you scan it, the Apple photogrammetry realizes that we don't want this plexiglass to be part of our model. We want you to ignore that and just do the object. So having things like, you see the brain is sitting on basically white, kind of a white cottony blanket. Uh, so having like a single color, white or black, works pretty well. If you look at the top image in the top left, you'll see they have this specimen here that's very complex. It's basically, a human torso hanging by hooks and strings, and they have a blue screen behind it. So some of these standard like movie and photography techniques also work with photogrammetry, and we're really just finding things as we go and improving the process as we go. But yeah, this light box works really well if you're using an iPhone because it fits right in there. And that gives you some nice even lighting. You can use studio lighting, but then it gets a little clunky because you do have to walk around the model several times. So it's nice to not have any lights or cords or tripods in your way as you move around these objects.
We just got a question from Frank asking if ITS offers this as a service for specific projects or consulting, as capital planning may want to explore VR walkthroughs of the upcoming new student residence building.
Yeah, that would be exciting. I'd love to talk to you about that. I've worked with the MD PhD program because the Tri institution is so large of a campus, goes to so many multiple buildings that, I've worked with them to try to map out that campus a little bit. Some of that using some of the 360 photos. And so, yeah, I'd love to talk to you about that. Another interesting new option we have for making these kinds of virtual tours now is the Apple Vision Pro. So this is a new device that we have a few of right now, and this allows the same kind of thing that we're doing with the 360 camera, but the photographer places it on their head and just literally walks to the locations and takes the photos on the headset that they're seeing through it as they're walking and doing it. And it's a really nice way to make these kinds of tours as well. So yeah, I'd be happy to talk with you about your project.
Thanks, Rob. Are there any other questions people might have? I'm gonna give you guys a minute if you're typing just in case to let it go through the chat. And for anyone who was late, we are recording the session since I've gotten a few notifications from people wondering. Yes, we are recording and we will send this out for everyone to look at in a follow-up email later today. You'll get a link to this recording, and I have taken note of a few of the links and apps that Rob has mentioned during the session, so I'll be sure to include those in the follow-up email as well.
Okay, well, thanks everyone for joining us today. And yeah, feel free to get in touch with me, Rob Dietz, and happy to help with any consulting or just giving you tips on where to find stuff or how to put things together.
Thanks, Rob. We're getting a lot of thanks in the chat. People really appreciating you showing them all of these cool 3D graphics. Hopefully, people are thinking of some cool ideas they can do within their own work and department. But again, I'll be sure to send that follow-up email out. It will have Rob's email. Just feel free to hit reply if you think of a question or want to, some type of consultation about or advice about how to use these tools. But thank you so much for joining us. Have a great rest of your afternoon and keep an eye out for that message. Have a good one, everybody. Thanks, Rob.
Thanks, everyone.